Hello everybody, in this video we are going to solve another problem live from LeetCode Stop Interview 150 problem list. So far we have solved all the problems up to container with most water. If you haven't checked out my videos on those problems, please go to my channel and check them out. Today we will solve the next one, which is threesome. Let's read the problem and make sure we understand it. It looks like the problem is of medium difficulty level. Okay, so given an integer array nums, return all the triplets, which is nums of I, nums of j, nums of k, which is one triplet, such that I is not equal to j, I is not equal to k, and j not equal to k, which means we are not really reusing any element from the array. And the sum of those elements is equal to 0. Okay. Notice that the solution set must not contain duplicate triplets. Okay, interesting. So before we look at the examples, one thing to, remember or recall is that we have done a problem which is can be considered like a prequel of this problem, which is twosome on this channel. In fact, we have done two variations of that problem, and I think they both belong to this problem list of Top Interview 150 on LeetCode. Anyway, nonetheless, one variation of the problem was that just find two numbers that sum to a specific target sum. It wasn't 0, but it was a specific target sum. And the other variation was given a sorted array, find two numbers which sum to a target sum. But in both those cases, I think there are two or three differences in this problem compared to that problem, right? Of course, one difference is that we have to find a combination of three numbers, not two numbers. But the other couple of differences, if I remember correctly, were that in those problems, we were only supposed to find as one pair. If there were multiple pairs that existed in the input array that sum to the target sum, we were not really required to find all of them. In fact, if I remember correctly, they had given a constraint that they will construct the input such that there is exactly one pair which adds up to the target sum. And even if they did not construct the input that way, we were just, we wrote the code that will just find a pair, not all pairs. While in this case, they are saying that we have to find all the triplets, right? That return all the triplets. So that is interesting, and that may change the approach, at least compared to the twosome problem that we did. And then it says, this is also interesting. It says, hey, notice that the solution set must not contain duplicate triplets. In the other twosome problem, I think we were supposed to return the indices of the two numbers that added to the target sum. While in this case, we are not supposed to return the indices. Looks like we are supposed to return the numbers themselves that add up to the to 0 in this case. The target sum is always 0 in this case. And that cannot be duplicated, which is interesting. And the reason I say that, actually, at this point, let's look at their examples, and then I'll see if actually it is worth taking another example to demonstrate my point. Okay, so the first example is nums is -1, 0, 1, 2, -1, -4, and the two triplets, and these are the values of the numbers. Remember, these are not indices that add up to 0 or -1, -1, 2. Yeah, that adds up to 0, and that's -1 here, -1 here, and 2 here. And then it's -1, 0, 1. Yeah, that adds up to 0 as well. And then, so those are the distinct triplets. And then they do say, hey, notice that the order of the output and the order of the triplets does not matter. Okay, so that's good. I mean, we could have returned this in different order, like this could have been before that. Or within each triplet, they could be ordered in any order we desire. So that's fine, that makes sense. Let's look at the second example, 0, 1, 1, and in this case, the output is empty because there is no triplet. There is only one triplet actually, and that doesn't add up to 0. And in this case, there is exactly one triplet, and that triplet adds up to 0, so that's actually what is the output. And the constraints are that the length of the nums array is between 3 and 3000 inclusive, and the value in the nums array is between negative 100,000 and 100,000 inclusive. Okay, I do want to demonstrate my point here, what I was saying. So not sure if it is really important to figure out the right approach, but just something I noticed. So I'm going to try to demonstrate with an example. So let's say that we have an array where, we have some duplicate values, right? So we have -1, -1. Let's say there are 4 -1s and there are 2 1s, right? And the triplets and let's actually write down their indices, right? So I'm just going to write down their indices here: 0, then 1, then 2, 3, 4. Sorry about the spacing there, but just a sec. Index 5 and index 6, right? So those are the indices. And if we were returning indices, if in the two-sum problem, we were supposed to return the pair of indices that add up to a specific target, you could say that, okay, hey, this -1 is different from this -1, right? And that is different from this -1 because they are at different indices, and you are still not reusing the same element as such. But in this case, they are saying that the triplet itself should be of values, and that should not be duplicate either. So for example, if we were allowed to repeat the value but not the indices, this -1 and -1 at index 0 could be paired with negative could be paired with this 0, the second 0, and that could be paired with the last one, and that would be one triplet that adds up to 0. But then you could say, okay, hey, this -1 can be paired with the same 0, and that can be paired with a different one, like this one, and that would be two different answers. And the reason is, if you write down indices, is that is when it is obvious. So let's say what are these in indices, right? We took the -1 at index 0, we took the 0 at index 1, and we took the 1 at index 5, right? So this is 0, 1, 5, while this guy is not 0. We took this -1 at index 2 actually, and we still took 0 at index 1, and we took 1 at index 6. So these two are different, and basically the triplets of indices is unique, 0, 1, 5 versus 2, 1, 6 or 1, 2, 6, but the values are exactly the same as the triplet. And in this problem, we cannot even have a duplicate value triplet, right? So the value triplet versus an index triplet is what I'm trying to distinguish between. Not sure if it really matters in solving the problem, but just something I noticed. Okay, so let's think of an approach. Like we always do, right? One approach is brute force. We consider all the triplets and see if they sum up to 0, and if they do, we add it to the answer list. But this is where actually, yeah, so this distinction will actually do matter. That brute force approach actually will not work without some additional logic. And the reason is, if we take the brute force approach, we will always only add a unique index triplet, but the values could be actually the same. And so a dumb approach, which is a brute force approach, will not work, and we'll have to do some duplicate checking, which is actually could be quite expensive. You have to use some data structure like a hash set to store all the triplets, and in the hash set we will make sure that we don't enter a duplicate triplet. We have to enter the triplet in a sorted manner so that it will check for the duplicate, and then we have to convert that hash set into a list. So that is going to be quite expensive, right? So yeah, it did matter that it's a duplicate is of the values and not just of the indices. Okay, so anyway, that brute force approach doesn't work. So I'm not going to try to implement it because it will definitely fail test cases. In fact, it will even fail this particular test case. Okay. Now, what's the other approach? Well, one thing is, because we have done the two-sum problem before, right? We could actually borrow from that. And I think we have done two variations, like I said. In the variation where the input array was not given as sorted, the best approach that we had come up with was O of n, and that used a hash table, right? We basically stored all the values into a hash table with their indices as the, with their indices. And then, for every number, we just looked up if a complement number existed by looking up the hash table in O of 1. So that was the approach we took. And we could use that as a helper, right? And what I mean is, so we could have an algorithm, something like this, right? So that actually, let's do this. So let's say there are three numbers are ABC, right? And so what we are trying to say is, hey, A plus B plus C equals 0. How many such ABCs are there, right? So what we could do is we could say for each, A in the input array A, capital A, or nums rather, right? So in the input array nums, we could just call helper of twosome that we wrote before, right? And we'll have to modify that helper a little bit because, like I said, the actual implementation that we did for twosome only found one pair, but we'll call a helper for twosome to compute all pairs, not just one pair. That's sum to, target sum, which will be 0 minus, 0 minus. That's sum to 0 minus. Well, 0 minus is minus, right? Negative nums of negative A, right? Basically, that for each A index or for each A in nums, yes, negative A, right? So 0 minus A is negative A. So for each A in nums, this is what we could do. We could actually call that. We'll have to still take care of some duplicate things, and we'll have to write the twosome such that it does not itself return duplicate pairs. And then we'll make sure that, we'll make sure that we don't use duplicate A's. So roughly that algorithm could work, right? And like I said, that particular algorithm can be done, the helper of twosome can be done in O of n. So if this is an O of n loop, so this is O of n, and this inside thing is also O of n, so that becomes an O of n square algorithm, right? So this itself is also O of n, and that becomes an O of n square algorithm. So we could do that, right? And that would work. And that uses extra memory of a hash table like we did. And then we did the second variation. So that is the other thing we can do is instead of using a hash table, an extra memory there, we could just sort the input array, and we have done that variation of the problem on LeetCode. Well, we sort this. If this array is sorted, then this inside, line can be done in O of n time without having to use a hash table, right? And so that is the second approach we could take. And I think that is a slightly better approach because sorting is n log n, right? So initial. So the second approach is just writing this variation down. Here we say first we sort nums, right? So before we do anything, we say sort nums array, and then after that for each, we still can call a helper or run the code, for twosome. But that now does not require a hash table. This just so the description remains the same, but the implementation does not require a hash table because if you remember, we did a two-pointer approach if the array is sorted, and that does not require any additional memory, and we could use that here. And like if you don't remember these details, please go through my videos on those two problems, the twosome problem and the twosome 2 problem, which where the input array is sorted, right? And so the thing that we can implement here is maybe let's do the sorting approach here, because like I said, it's slightly better in memory consumption. And the reason I say slightly better, not like really better, because we cannot say that the sorted approach actually uses of one memory, because like I mentioned in that video, if you are sorting something that the user gave you, that is not a good practice when you're writing a function yourself or a method yourself. You should copy that array and sort that copy, and that will use of n memory. And the reason is the user does not really expect you to change their array for a problem like two sum or a three sum or something that is seemingly supposed to only read the array, right? Read the values in the array. You could document in your function that, hey, you're going to modify the array, but then in some cases or in a lot of practical applications, the user will need a variation of that function or will have to write a wrapper themselves where they make a copy. So I don't encourage that, and I think we should make a copy ourselves and so on. Anyway, so for the purpose of this video, I'm not going to make a copy, but I will implement the sorting approach. So let's go through that. And we still haven't actually discussed how to handle duplicates. So let's actually spend a minute or two on that before we write the code. So how to handle not adding duplicates to our results list, right? So anyway, one thing we should do is that, okay, so actually sorting helps with that also. If we end up sorting the array, right, then what we can do is we can say, okay, hey, once we sort, then let's not look at the duplicate lefts and the duplicate rights when we do the left and right pointer. In fact, if just one of them is checked for duplicate, the other one will, the pair won't be a duplicate, right? So we don't have to check for both. We can either check for right or left, that the previous right is not the same as current right, and if it is, then we just skip that right and not do anything, right? So that would, I think, work to avoid duplicates. Okay, so let's go through that. So what do we first do? Well, we first do, so we sort the nums array, right? So let's do that. Arrays dot sort is a simple helper in arrays class which just sorts in place. And like I said, in real method, I would probably should probably create a copy of nums, instead of just sorting nums themselves. But in this video, it's fine to not create a copy. Okay, so arrays.sort nums, right? So we sorted it. After that, what do we do? Well, we have to run a loop for various values of a, right? Actually, we need a data structure to store our results, right? So let's do that first. So we say results equal to new. Well, array list is a good candidate for holding the results in most cases. So let's do that. And now we say, okay, hey, what are the various values of a? Well, a index, right? A index can be 0. A index is less than nums dot length plus a index, right? So those are the various values of a index. And we also need to check for the duplicates of a index, I think, because I mean that a should not be the same as the previous a, right? Yeah, I think we should do that. So let's do that. And it's pretty easy to check for that. We don't, okay, so here is what we do. We say if a index is greater than 0, which means it does have a previous value, right? And nums of a index minus 1 equal nums of a index, which means the previous value in the array is the same as the current value, then we just short circuit and continue the next iteration of the loop, right? So this will check for duplicates of a, right? So now we have a, right? We have a equal to nums of a index, right? Actually, since I'm just being a little bit nitpicky here, since I can just use that here as well, right? Okay, got it. So now we have a value of a. Now what do we do for b and c? Well, our remaining target for two sum, right, is equal to minus a, like we discussed, 0 minus a, which is minus a, right? And now we are just using our algorithm from the two sum problem, where we do a left pointer and a right pointer. So I will kind of cover that a little bit quickly here because we have a full video on that. But what we do is we say, hey, int left equal to a index plus 1, right? And what we are trying to do is we have a, we are trying to do b and c, right? Hey, what are the other two numbers which sum up to what? Minus a. If they sum up to minus a, then a plus minus a will be equal to 0, right? So okay, so left is that, right is equal to, we start from the last element, right? So that is nums dot length minus 1, right? Sorry about that, minus 1. Okay, so that is what we start, and we say while left is less than right. What are we trying to do? We are trying to figure out a pair. So what is B? Let's first do B equal to nums of left and C equal to nums of right. So those are our B and C, correct? Okay. What are we trying to do is we are trying to say that if uh, B plus C equal target, right? If the sum of B plus C is the same as our target of two numbers, in that case, we basically have a potential result that we should add to our results list, right? And that would be, let's say, results dot add. Well, actually, we need to create a list, right? So, okay, so here we could say array list of integer, let's say triplet equals new array list of integer, and then we add three numbers to it, right? We say, actually, you know what? There is an arrays.as list. Sorry about that. I just remembered that what we do in 3 or 4 lines can be done in a single line. There is an arrays.as list. We create a new array, and in this case, an integer array, because that is what we want to convert to a list. And we say a comma b comma c, right? Yeah, so I think what this one statement will do is what I was trying to do manually by 3 or 4 lines of code. So I just realized we can do this. Okay, so let me walk through what this is doing, right? So this is just creating a new array, this one statement, right? New array of size 3, and that will have a comma b comma c as the three numbers in it. But after we create the array, we make that array into a list using this arrays.asList helper function. And that now becomes a list of 3 elements, and that we add to the results, which is a list of lists, right? And so we have added one result. Now, once we do that, we can actually increment both left and decrement right. We can do both, right? Because we have added that pair, we have found our thing, right? Now, else if B plus C, actually maybe B plus C, I should also just do a int sum equals B plus C, and if sum equal to target, right? Else if sum is less than target, which means our sum is smaller than what we need to. Now, if it is smaller, we need to make it bigger, right? And how do we make it bigger? By incrementing left, because remember, right is at the rightmost element, which is the biggest number after sorting. So if we decrement right, we are going to make sum even smaller. So that doesn't work. So here we say plus plus left, and else is minus minus right, right? So this is pretty much what we wrote down. I mean, I could have written a helper for this whole thing, right? Like, which is two-sum, but this is what we implemented in the two-sum variation problem. And the reason I didn't do the helper is because I need to create a triplet. Well, I could still write a helper which can actually create a triplet. But anyway, now that I've written the code here, let me not waste the time in moving it to a helper. Okay, so that's that. Now there is one thing we haven't done yet. We haven't taken care of duplicates, right? And which means actually this will definitely end up adding duplicates, even though we have taken care of a value not being the same. So every time a will be different. But for the same a, or sorry, for the different a, uh, or for the same a, this loop could actually end up adding multiple duplicate pairs. So even though we have checked for a not being a duplicate, we have to check for b or c not being duplicate, right? And one is enough. We don't have to check both, because if c is not the same as previous c, then b cannot be the same, because our target sum is going to be different, right? If they are the same. Okay, so let's see how do we modify this for that. So I mean, like I said, we could either check left or right. So what I think we will use the same technique as we did for A. Let's just check for right. So if right is less than nums.length minus 1, which means it is not the last index, and that means we can access right plus 1 without getting an index out of bounds error. And so we say nums of right plus 1 is equal to, I'm going to take this also above like I did in the other one, is equal to C. Then we basically just do plus minus minus sign, and we continue, right? So basically what I'm doing here is, let me just go slow. I'm saying this is just to make sure that I do not, that I can access right plus one without an array index out of bounds error, right? The first part of the and condition, right? So that is just for that. And now this guarantees that I can actually do right plus one. I can access that. And what I'm saying is, if the element after right plus one is the same as the element at right, which is C, then we don't have to, we shouldn't even try this, because we shouldn't try this value of right, and we should just decrement it and then continue, right? So that's what we do, and we short circuit the whole loop, as in we don't break out, but we continue and we go back here after decrementing, right? I think that is that, and then here we return results, right? So let's go over this one more time, just on our example, right? So let's say this is the example. So let's copy that, and we will actually, yeah, go through that a little bit fast. First we sort, right? So after sorting, what happens? Minus 4, minus 1, then 0, 1, and 2. Is that it? Yeah, that's it, right? And oh wait, I skipped 0 somehow. So minus 1, 0, 1, and 2. Yeah, that is it. Yeah. Okay, so 1, 2, 3, 4, 5, 6 elements. Yeah, I think that's good. Okay, so once we sort, what do? We say, hey, A equals, or first of all, A index equals 0, right? And for that loop, A index equal to 0, let's see what are we doing. Well, for A index equal to 0, we say A equal to minus 4, correct? That's what A will be. And then after that, our target, sorry, so here, let me just do here, target becomes equal to 4, negative minus or minus 4, so target is 4. And for that target, we are going to run this loop. Left is, what is left? So left is equal to 1, A index plus 1, so that's 1. And right equal to always the last element, which in this case is 5, index 5, right? Okay, so left is 1 and right is 5. We start from there, and then we say, okay, hey, what is there? First we check, is the right, the right is not duplicate. So I'm going to skip that if condition, because it's not going to be true. But then we are sum is equal to B plus C. So sum becomes B is, nums of 1, which is negative 1, and this is 2, so sum is equal to 1. Sum is not the same as target, so we don't go into that if condition, but sum is smaller than the target. Yeah, sum is smaller than the target. Target is 4, so we do plus plus left, and so now left becomes 2, right still stays 5, and now sum becomes, sum is still, there is another negative 1, so sum is going to be still 1, and that negative 1 and this 2 is okay, I think, because the sum will still not, yeah, we don't have to check duplicates there. So left will be incremented, right will be 5, and that will become 0 plus 2, so sum is equal to 2, and then that will also not be equal to target, but it is still small, so left becomes 4, right is equal to 5, and that becomes 1 plus 2, sum is equal to 3. That is also not target, but now left and right become the same, and that will exit out of the loop because left has to be less than right. So I think that works. Now we say A index equal to 1. Now next A index, we start with A equal to minus 1 and target equal to 1, right? And then here we will start with left equal to 2 and right equal to 5. And that becomes sum is 1, and that is smaller, so we increment left equal to 3, right equal to 5, and that becomes right equal to 5, and 3 and 5 sum is equal to 2. Oh wait, sorry, this is the same as target. Here target was 1 and sum is 1, and since that is the same, we will add the triplet ABC, which is minus 1 and 0 and 1 to our list, right? And that point we increment left and we decrement right. So we've got left equal to 3, right, equal to 4, and that makes sum equal to 0, 1, 2, 3, and 4. That is also again 1, and so we will add another -1 and 0, 1. Wait, am I adding duplicates? 1 second. The right was 5, sum was 1, right is 5, so -1 and +2 is yes. So then this becomes, oh no, -1 and this, so this is sum is 0. Yeah, at this point sum is 0. So because it's -1 and 1, sum is 0. So we do not, sum is now smaller, still smaller. So we still increment left equal to 4, right equal to 4. And at that point, we do not compute sum, we break out of the loop because left is not less than right. So I think it works. Let me try to run this. Just wanted to check manually once just to get an intuitive sense of our implementation. Always a good idea. Okay, so that got accepted. So that's good. Now let's submit this and see on a larger set of test cases, like, are we actually correct? Especially the duplicate logic is very interesting. And okay, so we did get accepted. That's good. Well, it beats 42% of time only. So, okay, I think this is why, right? Because we fall into a category where 62% of the submissions are using the same runtime as us. And that's why we are only beating them, but we are in the equivalence class of that. So I think we are fine. And this seems like the best algorithm in terms of, the complexity. So with that, let us actually, I mean, the memory doesn't mean anything. Like I said, I mean, we are not using any extra memory. We should be using in real production code in most cases to copy the array, like I said a few times. But, memory doesn't mean much, memory percentage. Okay, so let's actually, just before we end this video, just make sure it's very obvious, but just for the completeness, like, talk through the complexity. We did talk through that when we looked at the algorithm, that it's O of n square. So I think we already covered that, but here it's evident, like, we have a for loop outside, a while loop inside, that in the worst case goes O of n time. And that is why our complexity is O of n square. Hopefully that was helpful. If you're liking what I'm doing on this channel, please hit the subscribe button on the channel or hit that thumbs up button on the video. I'll see you guys next time.